Hi, my name is Faisal Masood and I'm a Principal Architect at Red Hat Asia Pacific.
Hi, I'm Tom Corcoran, Principal AI Specialist at Red Hat. This is the next video in our series on the Red Hat Data Science Platform. See the description for the previous video on fraud detection. So we're going to use the same platform that we used in the previous use case, but this use case is going to be for NLP, or natural language processing. The same platform is used for all different data science use cases across your business.
Thank you, Tom. So in the previous slide, we talk about two challenges. The one challenge the data scientists face is ease of deployment their model to production and bring on the consistent development environment for them to do their work. So those two challenges, we'll see how the platform can abstract this in a variety of use cases. And today in the text classification model, our data science expert Saeed will take us through a new use case with the same tool set to get the benefits we described.
Hi everyone, I'm Saeed, Senior Data Scientist, Machine Learning Engineer at Red Hat. As Tom mentioned in our previous video, we had a discussion about the credit fraud detection. Today we want to select a completely different problem as a text classification, natural language processing. Text classification, that is the problem. And then for this particular problem, we receive some text from the customer in banking sector, and then we classify the text to various categories such as the car loan, credit payments, and then etc.
All right. So in other words, as a user, when I'm interacting with the banking app, and I type my need into the chatbot, the AI model will detect where that request needs to be sent to, and it will route that request to the correct department.
Yeah, exactly the same structure is in the same scenario happening in the chatbot. And here we want to follow the same routine that we did for our previous video. Again, we clone the code from the Github, and we can see the code. In this code, we just follow the same procedure of reading the data, do some defining the model, train the model, and testing the model, and deploy the model. We have the same procedure. Also, we provide two extra functionality as a MinIO for reading data from S3 buckets, and the other is MLflow for doing the experiments or tracking the hyperparameter in our experiments. As you can see, we read the data, we did some pre-processing on data. In this pre-processing contains the converting the variable to the float number, and then do some padding on the data to shape the input data in the fixed form, and then define the model based on LSTM, long short-term memory, and then train the models. You can see that we test the model with in terms of the performance, and you can see that confusion matrix. And the next slide, we can see how our model interpret the new data that's coming to, and then how it's assigned, how it's seen in various categories.
That's awesome, Saeed. So just to recap, you've seen a new use case today, as we saw previously with the fraud detection use case, where the platform can bring a consistent model lifecycle and a faster deployment and a faster time to value.
Thank you, Tom. I think, and as Saeed was mentioning, the classification that you did in the model can be used in a variety of use cases. For example, if you have a chatbot in the back and a user types some text in the chat box, that model can detect where he or she wants to go. As Saeed mentioned, it can be a loan, it can be credit card payments, or it can be any complaint, and you can route the customer to the right department faster, helping to improve your customer experience and bringing value to your business. And today, as usual, all the code is available in the Git repo, which is available in the link description below. And in the next video, we will talk about apply the same process and talk about how we can bring on time series and image classification within enterprise. Thank you.
Sorry. And the other things, because we talked about the